The stars above us are ancient, cold, unfeeling, but in their silence, there's a question that refuses to die. If the universe is home to billions of planets and countless galaxies, then where is everyone? This isn't just a question for science fiction fans or bored astronomers. It's the heart of one of the deepest mysteries in modern science, the Fermi Paradox. The numbers say we should have found intelligent life by now. The reality is, we haven't. Not a signal, not a whisper, just nothing. And that silence? It's deafening. It's led some of the most serious thinkers, scientists, philosophers, even former government officials, to ask, what if the silence isn't an accident? What if someone, or something, is deliberately keeping their distance? What if we're being watched? Imagine Earth as a planet-sized wildlife preserve, a controlled ecosystem, a sealed-off enclosure for a species still too primitive, too violent, or too unpredictable to be trusted with the knowledge of the cosmos. In this theory, aliens aren't absent, they're just hidden. And we might just be the exhibits in a galactic zoo. This isn't a conspiracy theory, it's a serious scientific proposition, the zoo hypothesis. And it offers one of the strangest, most compelling explanations for our cosmic loneliness. In this video, we'll walk you through the idea step by step. Not just what the zoo hypothesis is, but why some believe it might be true. Because if we are part of someone else's experiment, the question is no longer, where are they? It's, why haven't they made contact? And more importantly, what happens when they finally do? Where is everybody? That simple question, first posed by physicist Enrico Fermi in the early 1950s, has evolved into one of the most profound mysteries of our time. Given the age of the universe, the sheer number of stars, and the high likelihood of Earth-like planets, one would expect that intelligent life should have appeared many times. Some of that life should have had ample time to explore the galaxy, colonize planets, or send us some kind of signal. And yet, the silence is deafening. This contradiction is known as the Fermi Paradox, and it sits at the core of our journey into a theory that is as unsettling as it is fascinating. What if Earth is an alien zoo? To understand the implications of such a theory, we need to dig deeper into the paradox itself, break it down, examine its assumptions, and consider why the absence of evidence may not be evidence of absence. There are over 100 billion stars in our galaxy alone, and most of them are orbited by planets. Thanks to missions like Kepler and TESS, we now know that Earth-sized planets in the habitable zone, where liquid water can exist, are not rare. In fact, estimates suggest that there may be as many as 40 billion potentially habitable planets in the Milky Way. So let's ask, if even a tiny fraction of those worlds harbor intelligent life, shouldn't at least some of them have developed advanced technology? Shouldn't we have seen signs, radio signals, probes, or megastructures? Instead, we find nothing. No signals, no probes, no alien visitors. The Fermi Paradox forces us to confront this eerie silence, and it's here where our imagination begins to stretch the boundaries of what we think we know. One popular attempt to resolve the paradox is the idea of a great filter, a critical barrier in the progression from simple life to advanced, spacefaring civilizations. This filter could exist at any point in the evolutionary timeline. It might be that life itself is extraordinarily rare. Complex life is nearly impossible to evolve. Intelligence doesn't inevitably lead to technology. Civilizations destroy themselves before they spread. If the great filter is behind us, then humanity is incredibly special. But if it lies ahead, then our future may be doomed. However, there's another way to interpret the silence. Not as a tragedy, not as a failure, but as intention. A hidden rule, a purposefully maintained distance. This brings us to a more speculative, but equally serious possibility. The zoo hypothesis. Proposed by MIT astronomer John A. Ball in 1973, the zoo hypothesis suggests that advanced extraterrestrial civilizations know we're here and have deliberately chosen not to contact us. Not yet. Imagine a wildlife reserve. Visitors watch animals from behind glass, careful not to interfere. What if Earth is one of many such reserves? Planets observed from afar, studied, perhaps even curated, but not disturbed. We are intelligent, yes, but still primitive, still violent, still unaware of the true cosmic stage. According to this theory, the reason we haven't heard from aliens is not because they don't exist, but because they're intentionally quiet. They may be waiting for us to mature as a species. Or maybe, just like zookeepers don't consult the lions, advanced species don't see us as worthy of dialogue. Of course, this raises questions. Who decides we're not ready? What counts as maturity? And how would such a system be enforced across galactic scales? There is, as of now, no direct evidence for the zoo hypothesis. But let's be clear, absence of evidence is not evidence of absence. Consider radio silence. If advanced civilizations communicate through means beyond our understanding, quantum entanglement, neutrino beams, or gravitational waves, we may simply lack the tools to detect them. UAPs and anomalies. While most sightings have conventional explanations, some unidentified aerial phenomena, UAPs, remain elusive. Could they be probes? Watchers? Mathematical coincidences. Some argue that the fine-tuning of universal constants points to a designed environment. Could our zoo be part of a simulation or a terrarium tailored to sustain life? Each of these ideas on their own may sound like conjecture, but when we place them beside the silence, the odds, and the absence of any other reasonable explanation, the zoo hypothesis starts to sound less like science fiction and more like a hypothesis waiting for further investigation. This chapter is not just about speculation, it's about framing the question. Because the Fermi Paradox isn't merely academic, it challenges the way we see ourselves in the universe. If we're alone, then we are immensely precious. If we're not, then someone, or something, is choosing not to reveal itself. And that should make us pause. The zoo hypothesis doesn't answer the paradox, but it offers a lens, a way to make sense of the contradictions. So if you're still wondering, where is everybody? Maybe they're already here, watching.